Hello, hi guys. I'm Roman. Uh, Today I'm starting a new series called Learn with Me. I don't have a tentative name as of now. This is just temporary. I might change it in the future. But basically, the aim of the series is going to be sharing any learnings or any tips that I have that I come across my way while trying to learn this beast of a software called Houdini. Um, and in this today's episode, which is the first episode, I'm trying to go ahead and try to recreate this effect. Not till the end, not like polished, but I at least want it to be kind of in a working state. This is a video on the Houdini channel from the studio called Bureaucross Allman. I hope I'm pronouncing it right. They had a really nice, R&D or visual project that they did, where there is this can, and then it kind of has this deformation. And the way they did it is, first they had this geometry that was deforming, which later on they added cloth dynamics and simulations using vellum, which give it a more organic feel. But the first part that I want to tackle in this series is, how do you make this kind of fall off gradient at least, and you know get these shapes. They did a good R&D, BTS during the middle of this video. So this is, you can actually watch this and follow along. But there is a lot of gaps missing in the information, because this is just a quick kind of workshop event that happened. So they don't share like the full kind of process, but this is good enough to start with. And I really enjoyed watching their talk. So suggest you to watch this. I'll leave a link below. But you can see a few techniques that they used, which I'll also be showing you the same, and maybe talking a bit more on what goes behind and how we do it, and a bit of thought process, give you a bit of analysis. Uh, that didn't really sound like much, but what I'm trying to say is there's a lot of information that you might get, which is like nitty gritty and why, and answering the whys especially. So let's get started. Let me just find that visual just so that we can go back to this as a reference. Uh, Let me jump into my Houdin. I actually experimented a bit before jumping on this. I've been just experimenting a lot these days, trying to, relearn Houdini. I've been using it for the last 4 years, but never really got into it deeply. But the whole point of the series is to share whatever tips that I have gained as I go deep and deeper into Houdini. So to get started with, we need a tube. Um, Nothing much, it's a tube. What they had used is this divide node to get those really funky shapes that you saw, which is like this diamond cut shapes. There might be other ways to do it, but feels like this is more of a hack. Uh, all you have to do is just enable compute dual. This node is generally used to subdivide polygons. So if I check Bricker polygons and then really reduce this, you can see the geometry increases. So it's just to give resolution, but for some reason there's this compute dual button in this subdivision kind of centric node, which I'm not really sure why or how it does its thing. uh so I have to like maybe look into that. Maybe I can make another video on it if it's really important. But you see our tube shrank, and the reason is that because we don't have enough rows, lines going through our cylinder. It's so we just have to increase our rows, and you can see we get some more subdivisions. Then it starts to maintain its shape. I think 7 is a bit too much, and the diamond shape kind of really depends on how many rows you have. So I think 4 for now is okay, and then I will just increase the height of the cylinder so that it's a bit more looks a bit more like a reference. You can also see that the shape is not really maintained. So if I just template this and view this, so you can see that original tube is kind of longer than the subdivided one. So to fix that, there is this node called match to size, match size. It needs two inputs. One is the new input which we have, which is this subdivided mesh. So I'm gonna feed that into the first input, And the second input that it needs is the original mesh. So it's going to try to, um, adjust the size or the scale of the new shape to the original shape. Right now it does nothing, but you can see we have a bounding box. So essentially what it's going to do is try to rescale the new shape to fit the bounding box of the old shape, if that makes sense. Um, you just have to able scale to fit. That way the new shape scales, but still it's not really, scaling up to what we wanted it to be. There's still our effect. If you can see, this is our old tube. You just, again, simple fix, have to just uncheck uniform scale. So that way we are telling this node, okay, you know what, you don't have to scale in XYZ uniformly. You can also scale in Y axis more than X and Z, and so on. So that way it actually fits the bounding box. Else it's trying to, scale uniformly. So now that's done. I think um I'll add one more row. Yeah, that looks better. Cool. Now it's like we're 30% of the way there. What we have to do now is kind of make the gradient, right? So to do that, there's this node called attribute warp, and I should have maybe said this in the beginning of the tutorial. This is not a beginner's kind of tutorial. Maybe it's somewhere between beginner and intermediate. Definitely not like a pro level tutorial, but if you're dabbling in Houdini, or you've been using maybe for a few weeks or a few months, these nodes and terms might be, um, you might recognize these nodes. But if you're a complete beginner who's never used Houdini, this is not a tutorial I would suggest you watching. I should have told that in the beginning. I'm sorry, I don't know how long we are into this video, but I will just, go through it for now. Um, so yeah, once we have an attribute warp, this is where we can kind of introduce our gradient. It's really simple. We have to take our position data. So if I right now feed the position to color, which is CD, you can visualize how the position actually, the is represented through color. We are only concerned with the Y gradient, so that's top to bottom, and we can split the position value, which is a vector, into a float through this node called vector to float, and that'll get us access to the X, Y, and Z values of the position. Right now we are only concerned with the Y, so I'm just going to take the second input, which is the Y, and feed that into our color data. Later on I'll output this as something else, but for now, to just visualize it, it's better if I just output to color. Next, I'm gonna put in an add node in between these two, and I'm just gonna add in a parameter. Parameter is just going to be allowing us to access this value from outside the attribute warp, so that we don't always have to jump in back to attribute warp. I just name this to, let's say, offset, right? Cool. I think that's it. So you see, because of that parameter, we are able to control this offset value from the SOPs, right? From the SOP level. It's only going to between 0 to 1, and to basically change any interface, the value of any interface, you can just click on this settings, go to edit parameter interface, find the parameter that you created, and let's say my float range, I want it to be -1 to 1. Cool. So now I have this. One other thing, I don't want this gradient to be like super smooth. Right now it's like so smooth. One other thing must have forgot to mention is we have to change this from run over points to run over primitives. That way, you can see like the massive difference it made. As it runs on primitives, we get, like really cut out shapes instead of like a smooth gradient. What it tries to do when it's running more points is interpolate between each point. So if there's a point here and there's a point here, it's not really going, it's like trying to also fill in the data between the points. So if this is 0 and this point is value is 1, it's trying to going to, do like 0.1, 0.2, 0.5, and try to interpolate between those values. But if we switch to primitives, it treats one primitive as a, one value. So if this primitive is 0.5, and the next primitive is maybe 0.8, it's not going to interpolate between those two. It's going to be like constant. It's not going to be interpolating. So that way we get a very nice shape for the color. Like I said, I don't want it to be this smooth. So what I'm going to do is put in a multiply. That way we can kind of increase the, let's say, the clamp or you could also put in a ramp actually. Let's say a ramp parameter. I have not tried this, but I'm pretty sure this will work also. And with the ramp, you can, kind of adjust the strength and stuff like that. And you can play with the offset. You can see now we don't have that gradient, but we do have a slight gradient still. One other thing, before I put this into attribute warp, they did triangulate this. So, just search for triangulate and it gives you a bit more shapes to play with. So that's that. So you get now this. Cool. That's done. So now let me see what else we have done. So we did the attribute warp. These two are a bit more kind of maybe that's for another video, but yeah. Now what we have to do is kind of transfer that to a higher polygon mesh. Right? Right now there's a low poly mesh, and instead of feeding it to CD, I'm going to be exporting this as a custom attribute. So let's search for bind export, put it into bind, and I'll call this mask. Make sure it's float because it's float. Cool. We can't really visualize this, but don't worry for now. We can control middle click, enable the mask, and we are able to see. Cool. I'll do one custom code here, so that way we don't have to keyframe this. I want it to play, from -1 to 1, but I don't want to like kind of, set keyframe. So what I can do is, let's say $F, which is for frame, sorry, fit $frame, comma -1, comma 1, comma 0, comma 1. Good. Let's see. Wait a minute. No. Sorry. 1, 2. Can you tell? Oh, I have to put at F. My bad. Sorry, my bad. There was a couple of mistakes I did in this code. Initially, I had it at F. At F, you only really use it if you're working inside Vex. Right now, we are working inside the parameter context, so it doesn't really understand at. It's using $sign. So that's my bad. But basically, what I'm doing here is using this fit function. So it's trying to going to fit the $frame, $F, which is the frame value, right? Which goes from 1 to 30 between -1 and 1. So basically, I'm saying, hey, I'm trying to run till frame 30 and try remapping 1 to 30 to a new range, which is -1 to 1. That's the fit function. So you can see we have an animation now. Good. Now what we have to do is subdivide this. So I'm going to be using remesh. There is this quad remesh beta. I'm just going to plug that in and increase the byte count to maybe 50,000. That should be okay. You can go further, but for this tutorial, I'm just keeping it, less. Next, we have to transfer the attributes, the mask attribute, to this new quad remeshed geometry. Right now, we don't really have that because we remeshed it, so it's all gone. So what we have to do is use attribute transfer, and it requires two inputs. One is the geometry to transfer attributes from, that's going to be our low poly, and then the geometry to transfer the attributes to, that's going to be our remeshed geometry. Now, if I visualize that, you can see this is also where I kind of faced issues initially when trying to kind of decode their talk on the YouTube channel. So you can see it's supposed to kind of technically work. I mean, I just want these shapes to kind of be transferred to the new shape, right? Like the shape itself is the same. It's not really changed. Um, but for some reason, I get this. So the reason why that happens is, I mean, you can play around with the distance threshold. You can see that it's trying to do something, but it's not really working out. So to fix that, what you really have to do is, first of all, I'll maybe explain why it happens. So the reason why it happens is, well, I'm trying to transfer the primitives, right, from the low poly to the high poly. And attribute transfer works on a, you could say, point by point basis. The way it's seeing primitives is as a centroid. And what's a centroid is nothing but the exact center of every polygon. So for example, if I were to take the center of this, let's say this polygon, it might be somewhere here. And if I try to take the center of this polygon, it might be somewhere here. And that's exactly how attribute transfer is seeing these polygons. It's not really seeing these polygons as a shape. We see it as a shape, but it sees as a point in space. So when you see the, you know, the color data, and if I try highlighting this, you can see that each color data is trying to expand from each center of each polygon, if that makes sense. Hopefully I explained that properly enough. It's trying to do that, and we don't want it to do that. We wanted to see the shape as a shape, right? Like, we don't want it to see it as a point in space, because that's just the way it does its thing. So to kind of circumvent that, we have to do a bit of hack, which involves in basically using a scatter node. Sorry, one way you could kind of overcome this is, let's say, now that we know each the transfer is being taken place on each centroid, to kind of overcome that, you could think, let me subdivide my low poly and have more polygons. That way there will be more centroids. To show you, I'm gonna take my divide again, right? I'm gonna take my divide with the node again. And like I said before, it's mainly used for subdivisions. Like, for example, in this case, I'm going to subdivide it using this Bricker polygons method. I'm gonna get like a really tiny, um, I think that's okay for this visualization. So you can see right now we have a lot of polygons, right, on the low poly. Now, if I go to attribute transfer and enable the visualization again, you can start to see that, okay, we get that shape now, and that's just because we have more polygons. So each polygon has its own centroid, and it's just trying to kind of grow from that shape. This might not be the best representation, but you get the idea, right? This is one way to do it, and this is how I initially did it, because in their presentation they didn't really talk about how you do all this, because that's not really the point of that presentation anyway. But for this tutorial, that is one of the points. But it's kind of like really, I mean, a bit slow, especially right now. It's still kind of too jagged and a bit of a mess. So what you can do instead, and the way they have done it, is they used instead something called as a scatter node. Basically, this scatters a bunch of points onto the mesh, right? So right now I have the scatter points running on the low poly. Now this is too less, so let me just maybe put in 50,000 for now. So we have much more polygons. And in the primitive attribute, so right now we have the mask on the primitive as a primitive attribute, and right now the scatter points don't really read primitive attributes because we have nothing mentioned here. So let me mention mask, which is the name of the attribute which we initialized. So now you can see it copies the primitive attribute onto every point. So now it's a point attribute, right? So if I go and see, it's now a point attribute. Um, that's fine. Let me maybe increase it a bit more to, let's say, 100,000, so that we have a bit more resolution to work with. Now, let's do it again. So I'm going to feed the high poly into the first input of the attribute transfer, and the uh, now the scattered points into the second input, which is the geometry to transfer attributes from. Let's see what we have now. So we don't have anything primitives anymore. So it's going to be from copying from points, because the mask has been transformed through the scatter node. So I can just copying everything. So I can just put in mask for now, in case if I only wanted to copy mask and nothing else. So you can see right now we have much more clearer lines, and the reason why we have a bit of kind of jagged lines is also because of the high poly, because we don't have enough topology. So if I put this to 100,000, it's, I don't know if it got a bit better, but you can also increase the number of scatter points. So it's, it's slowly getting better, but um, the real magic comes from, sorry, the real magic comes from this blend width. So if I put in a value of 1, or maybe actually more, or actually, sorry, max sample count. So this is going to blur out the attributes a bit. So you get a really nice result like this, right? So now we get like a really clean and blurred out attribute. Cool. Now all that's left to do is, let's see, we have a tube, we have an attribute transfer. Okay, that's pretty much it. So let's have a tube. So basically this tube is going to be the same tube from the original that we have. Or I think I still copied the one from previously. Let me see. Right. So now we have to blend between two shapes. So right now this is our final shape, you could say. And we also have this original shape, right, which is the can cylinder. So let's just increase the number of geometry so that it's a bit more round and smooth. So I'm going to put it to 96. Let's go and put in array node, and let's just put in this like that. So the second input is going to be our collision geometry, which is the tube. And the first input is going to be our deformed geometry. So we are trying to now take the deformed geometry and project it onto the cylinder so that it's, nice and even. It's not deformed. So in the array node, you just have to change the method to project raised to minimum distance. So what that does is, not really sure why. Okay, we can hide geometry. Yeah, good. So right now our deformed geometry has been projected onto the tube, which is this, and we get this, right? So it's the same as the tube geometry. But now if we take a blend shapes, we can input the tube into this. Now if we try to blend, we can see what happens, right? So what I just did is project, first of all, in order for blend shapes to work, and this is what they, I believe they did. In order for the blend shapes to work, you have to have the same geometry, but you can deform it any way. So that's the reason why we kind of projected this deformed mesh onto the tube, so that we get the deformed mesh as a tube, if that makes sense. And because it's one geometry, we can blend between the two shapes. It's like blending between two states, for example. Right now, we don't have that mask affecting this. So over here, you can enable this and put it to set from attribute. And since our attribute is already called mask, we already immediately see that result. Now, if I try playing this, it's going to be a bit slow because I have too much polygons and whatnot. So I'm just gonna decrease it by half. Even this, just make it 50,000 on scatter and 50,000 polygons on the high poly. Just try playing this. So you can see the way it kind of like, it's really cool. I can just choose flat shaded, you know. So yeah, that's the first part of this. Maybe I'll put another part to this where we kind of go through how to set up the vellum constraints and get the cloth simulation going. I haven't really figured that out, but this is just the part which I figured out and I thought of sharing with you as there's a lot of information I kind of learned. So hopefully some of them got through to you. And yeah, that's it. Thank you.